All right, good morning, good afternoon, good evening, everyone. Thanks for joining today. In today's event, I will be talking about Redis Enterprise on Kubernetes. My name is Vic Kelkar. I'm product at Redis Labs. So welcome to the event, and let's get started. So for today's agenda, I will be doing a very brief introduction to Kubernetes and Kubernetes primitives so that we all have the same foundation before we start diving deeper into Redis Enterprise on Kubernetes. So once I do the introduction of Kubernetes primitives, I will also introduce Redis Enterprise and Redis Enterprise advantages. Once I am able to showcase those advantages, then we will jump into a live demo where I will show you a running Kubernetes cluster, which is running a Redis Enterprise cluster on top of that. So I will also have a couple of resources slides at the end, and finally I will open it up for questions. So with that, let's dive right into the Kubernetes introduction. So I think before we sort of start introducing Kubernetes primitives and concepts, I want to take a step back and talk about, why Kubernetes and why would you want to use the Kubernetes platform itself. So there are a couple big points that stand out on why you should be using Kubernetes. These days, containers are becoming the standard unit of deployment. 10 years ago, it used to be VMs, but now we are living in a containerized world. Kubernetes offers you the advantage of having stateful as well as stateless workloads in the platform. And I think that's why it's gaining a lot of traction. Another big driver for Kubernetes adoption is the adoption of microservices. So microservices, for everybody's benefit, is essentially you're taking a monolithic app and you're breaking them down into smaller microservices that have typically a single concern, and then you put them all together to develop your application stack. So these are the main drivers behind Kubernetes. So let's talk about what does Kubernetes do, or what does Kubernetes provide to its customer base and its users. First of all, like I said, Kubernetes is essentially a platform which orchestrates your containers. With microservices, you have a monolithic app that got broken down into 12, 15 containers, for example. And then the question becomes is how do you orchestrate and manage the life cycle of those 15 containers running in production? So Kubernetes provides that abstraction for you so that you don't have to worry about the life cycle management of your containers. Kubernetes itself has a scheduler for the containers, and it will take care of scheduling your containers, decommissioning it, scaling it up as well. So Kubernetes is really good at scheduling and resource management of your containers in a production environment. There are a couple built-in bells and whistles that are included with Kubernetes. A couple of them to highlight here is it does provide basic health check for your containers. So there is a liveness probe and readiness probe already included in Kubernetes. So it's basically, if you can think about it, it's bells and whistles included, beyond in the platform itself. Another key advantage of Kubernetes is it does allow you to do rolling upgrades and updates. And if you're using stateful sets, it's taking advantage of those primitives to do an ordinal upgrade of your containers that you have deployed. And one of the things or advantage of Kubernetes is around the declarative definition of your resources running inside of Kubernetes. It's in a simple way of putting it, you have your application described in a YAML file, and that allows you to maintain different versions and configurations in a Git repo, for example, and allows you to push your production container configurations into the Kubernetes cluster. Now, once you have about 15 or 20 containers, one of the key things and important things becomes around how do they discover each other. So Kubernetes provides the service discoverability aspect of running your containers in a platform. So these are the main sort of advantages of Kubernetes and why you would want to use it and what is included in a basic Kubernetes cluster. So let me now move on to, talking about all the Kubernetes primitives. I quickly want to walk you through all the primitives that we are going to be touching on later on today in the demo. So I wanted to provide a clear definition and exposure to the Kubernetes primitives so that you guys understand how we have deployed our Redis Enterprise release in the demo. So the first primitive or concept I want to touch on is the Kubernetes concept of node. A node is essentially a VM that provides runtime for your containers. So when Kubernetes schedules your production-ready containers, it normally will put it on a physical node or a cloud VM on which there will be resources like CPU and memory that will be shared by your containers. Another concept in Kubernetes is a pod. Pod in Kubernetes is essentially a basic unit of deployment. So pod will typically contain one or more containers in your application. So for Redis Enterprise, what we are doing is we are trying to maintain a one pod to one container ratio. But it is also important to note that a pod can contain multiple containers. The ability to define a pod which has multiple containers allows you to co-locate your containers onto the same node. So that's an advantage of describing and running a pod. The next primitive or concept in Kubernetes I want to talk about is service. The service is essentially a group of pods that provide a service or a network service on a particular port. So in Kubernetes, when you deploy multiple instances of your pod, end user should not have to remember or should not have to figure out where your pods are running. So a service essentially is giving you that level of abstraction which allows you to simply call up the service and one of the pods will serve the request and the traffic that's coming in from the user. Another sort of concept I want to talk about is around deployment. So deployment is essentially a declarative version of all your running pods. So a service and a pod combination will essentially become your deployment. And this allows you to, in a declarative way, defined and expressed in a YAML file, allow you to schedule a deployment so that the Kubernetes scheduler can take ownership of all the resources that are required for the deployment to function. Another key concept in Kubernetes, which was introduced originally in Kubernetes 1.7, but it became generally available in 1.8 and 1.9, is the concept of stateful sets. Stateful sets are essentially pods that have persistent storage attached to it. So what this allows you to do is have persistent workloads once you take advantage of stateful sets. Another concept that is worth emphasizing here is around Kubernetes controllers. Controllers are essentially, like the name applies, it controls a set of events. Or another way of putting it is it's a loop that reconciles the current state versus the desired state. You can write your own controllers, like Redis Labs has written their own controller for our release. By default, there are various controllers that come built in with Kubernetes, but as an end user, you have the capability of writing your own controller. So let me just finish off with the key definitions of all the Kubernetes primitives that exist in a cluster. Another concept worth noticing is the ability to describe a load balancer. Now, you may have multiple cloud environments, public clouds, and each of those clouds has a slightly different variation or implementation of a load balancer. So the Kubernetes primitive load balancer itself, when you describe it, the underlying API layer will then translate that load balancer requirement into a particular cloud-specific load balancer. Kubernetes, starting with 1.8.1.9, I think, is starting to go towards a strict namespace concept. So I think it will get introduced in 1.10, I believe, or 1.11. Essentially, namespaces allow you to slice up your Kubernetes cluster into multiple isolated segments so that you can maintain that separation between business units or between projects or between different owners that may be sharing a single Kubernetes cluster. So namespaces are a very good and powerful tool if you want to think about doing multi-tenancy in a Kubernetes cluster. The next couple concepts that I should mention are around storage and how you achieve persistent storage on a Kubernetes cluster. So with Kubernetes joining CNCF, they came up with a particular way of storing and exposing storage in the Kubernetes clusters. So they're working on an SNI, a storage network interface, which allows third-party vendors to bring in their storage capabilities onto a Kubernetes cluster. But from a Kubernetes perspective, having these abstraction allows an application developer or a service owner or service publisher to just use the abstractions and not worry about the underlying storage integration. So persistent volumes essentially allow you to define the storage that is available throughout the cluster, whereas PVC, persistent volume claim, allows you to request a slice of that storage for your application. Another thing that you will notice in the demo is my kubectl command line interface that I will be using to demo the running Redis Enterprise. So just wanted to mention the CLI is called kubectl or kubectl. And one of the things I think last week, Kubernetes and the Helm project in Kubernetes officially became part of the CNCF Foundation as one of the main projects. So Kubernetes Helm is essentially a tool that is used to streamline the installation and managing of your Kubernetes applications. And in this demo, we are going to be using Redis Enterprise Helm chart to do the deployment of our Redis Enterprise release. This essentially helps you deploy all your resources in a very descriptive and streamlined manner. So these are essentially all the primitives that I wanted to emphasize today about Kubernetes. And I'm now going to switch tracks and start introducing Redis and Redis Enterprise. So let me just quickly start off by telling you about Redis. So Redis is in-memory NoSQL database platform that is used to perform operational analytics and hybrid use cases. Redis Labs is the home of Redis and Redis Enterprise. One of the core contributors of Redis OSS, Salvatore, works at Redis Labs. So that's the relationship between Redis and Redis Labs. Earlier in the webinar, I touched on the fact that containers are becoming the standard unit of deployment. So I just wanted to highlight one of the data points that I came up with for this webinar. If you go to Docker Hub, you will notice that Redis is the most downloaded container image from the Docker registry. So we are pretty popular among developers who are trying to containerize their applications. So what makes Redis so popular? So let's talk about some of the key differentiators that exist in Redis. So let me start off with performance. Redis prides itself in being highly performant NoSQL database. Another key differentiator for Redis is the simplicity. Redis is, like the image is shown here as Lego blocks. Redis data structures allows you to compose your applications in any format that you like using a combination of these data structures. So right now we have 10 data structures that exist in Redis, and we always are looking to expand this data structure set. The third differentiator that Redis is around extensibility and the versatility of modules. So if you think about Redis core, the Redis core can be extended using modules, and these modules can be tied to a specific use case that you might be thinking of, or if they don't exist already, you are welcome to use them and extend it by writing your own module. Now, Redis Labs has its own certification program for modules if you want to participate in that, but you're also free to extend the Redis core capability and write a custom module that meets your needs. I'm going to dive a little bit deeper into the performance aspects of Redis. So what you're looking at here on the left graph in front of your screen is a comparison study that was done by a consulting group, which is highlighting the throughput capability of Redis and the low latency that you observe during that throughput. So on the left graph, what you're seeing is you're noticing three competitors who are trying to achieve a throughput, and the line graph is essentially showing you the latency. So as you can see from the graph, Redis was able to achieve a very high throughput with very low latency. On the right side of this slide and the graph, what you are noticing is a study that was done by Google, and it was posted on the Google blog site, which was trying to demonstrate what it takes to achieve 1 million writes per second. And again, we did a quick comparison of a couple of the competing technologies out there. And if you notice, it took a couple of the competitors a lot of resources to achieve that 1 million writes per second. Whereas Redis came in with the lowest total cost of ownership, the lowest amount of footprint, but it was still able to achieve the 1 million writes per second. So let's talk about why Redis is so popular and powerful for developers and all the solutions out there. I just wanted to highlight some of the key solutions that Redis is able to serve and service. Some of them may include e-commerce, like session management. You have personalization, which may include a recommendation engine. We have a Redis search module, which allows you to have search capabilities inside of Redis. Then you have social apps. You might have gaming platforms where you might be doing leaderboards. You have fraud mitigation, which can be done through sets and sorted sets. So Redis provides you all these capabilities, including IoT and metering. And all these solutions are possible because of what's in the middle. Redis is very close to real-time delivery of your data because it's mostly run in memory. Another sort of key differentiator for Redis is around these three, what I would like to call pillars. So first, Redis is super fast, so it is highly performant and it's linearly scalable. It has an extremely fast built-in search and performance capability. And the next sort of pillar to talk about is it's very reliable. So it is able to recover from failovers gracefully and very quickly. It does provide you with the ability to have super fast access to your data because it's running in memory. And one of the key aspects is you can configure Redis in various modes. You can do replica of, which is active passive. You can do read-only replica. But I think one of the key differentiators here is around CRDT, which is active-active replication across geographies and data centers. And the flexibility I touched on a little bit earlier, it is provided through Redis modules. It is provided through various deployment options. You can deploy Redis on-prem, on cloud, hybrid, managed. And then finally, it also helps you lower your total cost of ownership by using technologies like RAM and Redis on Flash. Let me quickly talk about the Redis Enterprise architecture before we dive into a demo. So what you're seeing in front of you is a typical deployment of Redis Enterprise. We typically deploy a cluster of 3 nodes or odd number of nodes in order to maintain quorum. What you see at the bottom layer, which is highlighted in red, are essentially your database shards. They are typically running the same Redis OSS version that is out there in the community. What we do at Redis Enterprise is we add an additional layer which provides almost zero latency proxies that route the traffic between the shards and sort of help manage the cluster and the nodes themselves. So they're using node watchdogs and cluster watchdogs to check the health of the cluster and then do management of the cluster and placement of the shards. So that additional layer helps you increase your utilization of your VMs or servers, because on the OSS side, it's single-threaded, but with a transparent low-latency proxy, we are able to take advantage of all the resources available on your servers and cloud VMs. One of the key things to highlight here before I move to the next slide is our share nothing symmetric architecture. What that essentially means is all the nodes in a Redis clusters are identical. They have the same bits, software bits that are running. So there is no separate roles that are assigned to each node in the cluster. All the nodes in the cluster have the same identical software running on it. Earlier, I quickly talked about the deployment options available for Redis Enterprise. Some of them are very quickly, you can deploy it in cloud, any public cloud that you can think of, AWS, GCP, and Azure. We also have this ability to do a VPC-based deployment, where we fully manage Redis Enterprise cluster for you. You provide the VPC, we provide the Redis Enterprise service running inside of your VPC. And the third option is around software download, and that software can actually be running on physical hardware in your own data center. It could be running in your cloud VPC account that you manage yourself, or it could be running on a platform like a microservices platform like PCF, OpenShift, or Kubernetes in this case. So I think that pretty much covers our introduction to the Kubernetes primitives and what is Redis Enterprise and how beneficial it is for application developers who are trying to use it in a Kubernetes cluster. So what I'm going to do now is switch tracks and dive right into the demo portion of this event. So let me first describe what the architecture looks like for Redis Enterprise in a Kubernetes cluster. So what you're seeing in front of you is essentially a Kubernetes cluster, and we are describing our service. So like I mentioned earlier about the concept of stateful sets, so we are taking advantage of stateful sets in Kubernetes. We are deploying our Dockerized container images in a pod, and 3 pods or 3 nodes of Redis Enterprise typically make up a Redis cluster. And the way we expose that to the rest of the Kubernetes cluster is by having a headless service which the developers and other applications can bind to and access their Redis database. So this is the overall architecture of Redis Enterprise. And let me now quickly, I'm showing you guys a static image of how I deployed Redis Enterprise in the Kubernetes cluster. This is a little bit of an eye chart because I wanted to get all the information in a single image. But essentially, what I want you guys to walk away with is to realize that using our Helm chart, which we have released publicly on GitHub, you can do a 3-node Redis Enterprise deployment in your Kubernetes cluster using a 1-line Helm install command, like you see in front of you. And also, I sort of pre-staged the deployment because I wanted to save some time during this webcast and not worry about the time it takes to bring up the Kubernetes cluster and to bring up the VMs and pods. But again, the idea here is Redis Enterprise does have a Helm chart which you can use. And if you notice in this screenshot as well, I have used some specific override values. So users have the ability to define and change the defaults that we have set in our Helm chart. So let me, at this point, switch to my terminal window and kind of show you what a typical Kubernetes deployment looks like for Redis Enterprise. So what I'm doing at this command line is I'm essentially grabbing all the services, pods, deployments, and stateful sets. So these are all primitives that we talked about earlier for Kubernetes. So in this command, I'm essentially grabbing all those resources and displaying them. In the -n is for namespace. And when I deployed the Helm chart, I deployed it in a namespace called Redis Enterprise for, it's a big word, so I shortened it to RE, stands for Redis Enterprise. So let's execute this command and see what kind of resources and what is the footprint of Redis Enterprise when it is running on a Kubernetes cluster. So I guess typical internet problems, it's a little slow, but here we go. So let me walk you guys through what you are seeing in front of you from bottom up. So essentially, the last line here is kind of showing you that I have a stateful set running. I have 3 desired and 3 current, so I think we're in fairly good shape. The scheduler was able to schedule and run the 3 stateful sets that we needed. The next line above that is the Redis benchmark tool. I am basically using an open source NoSQL benchmark tool called Memtier, which is available if you go to our open source website, oss.redislabs.com. This will showcase how you can get to the Memtier benchmark tool. So instead of writing an application, I'm essentially using a benchmarking tool to connect to the database. And then above that line is essentially the controller. It's a specialized controller that we wrote. The whole job of this controller is, again, like the controller concept, it's a loop. So it listens in for the events and it publishes a database endpoint as soon as it is created in Redis Enterprise. So 3 lines above these are around Redis Enterprise pods. So since we are using stateful sets, you can see they have an okay, I can't say it. Yeah, they are numbered starting with 0. There's another way of saying it. So essentially what this allows you to do is do a graceful upgrade of your containers when you get a new version of Redis Enterprise. So Kubernetes is smart enough to first bring down Redis Enterprise number 2 pod and bring up the new version on a different node. If everything goes well and if the readiness check passes, then we know the new version of the software is working fine, and then Kubernetes scheduler will then proceed down to the next one, which is 1 and 0. And this is how a rolling upgrade of a Redis Enterprise release will happen. Switching tracks a little bit up. So what you see in front of you is the Redis Enterprise UI. Redis Enterprise UI, we essentially have the same software running on-prem, on cloud, or in a Kubernetes release. And using a load balancer construct that I talked about, I am exposing that web UI, which we will go to in a bit, to kind of show you what the web interface looks like for Redis Enterprise. The first 2 lines that you see from this command line is around the database that I have created and set up for the demo DB. So what essentially that does is, once we create a Redis Enterprise database, it essentially publishes an endpoint that developers in this Kubernetes cluster can attach their applications to. So in this case, like I mentioned, I'm using a benchmarking tool called Memtier. So essentially, I deployed another container which is running Memtier inside of it, and it is binding to this demo DB cluster IP and port number. So this is the typical footprint of a Redis Enterprise release running on a Kubernetes cluster. So let me quickly continue with the demo and show you what it looks like from a UI perspective. So I'm going to quickly switch back to the terminal to kind of highlight that we have configured a load balancer. So the IP in this case happens to be 35.185.246.54. So when I switch back to my web browser, you will notice that I am logging in to that IP, which is exposing port 8443 where we can access the Redis Enterprise UI. What you are seeing in front of you is essentially the benchmarking tool that is generating traffic for the database I have pre-provisioned already. So as you can see in front of you, on a Kubernetes release, Redis Enterprise is getting over 1.5 million operations per second with close to 0.5 millisecond latency. So it's extremely performant and has a pretty low latency. As you can see that Kubernetes with its own service discovery is super fast and performant, and you also with this UI have advantages to looking at some of the other metrics that a developer or a service owner may be interested in. So if you come down here, I think all these metrics are included in the dashboard by default. So you can quickly see and scan how many reads, writes are happening, what is the used memory, what is the database size of your Redis database. So all these sort of key metrics are available to you through the Redis Enterprise Web UI. Another quick demo I want to do is around how do we create databases and what does that look like in Kubernetes. So we do have a REST API for Redis Enterprise, so you can create and automate database creations using our REST API. But for this event, I will just use the web interface. So as you can see on this Redis Enterprise cluster, which is running on Kubernetes, at present, there is only one database, which is being used by the memtier tool to generate load and show you the performance. So let's quickly go through a quick exercise of creating a new database. So I'm going to be very original and call it demo DB2. I'm going to give it about a 5 gig footprint. And then let's quickly create that database to see what happens on the other side when you go back to the Kubernetes CLI. So I think one of the first things that you want to notice is when you create a database, on the web UI, you will see the port number that is being associated with this database. So on this port number, the database endpoint is being published. So what does that look like on the Kubernetes side of things? So let's quickly switch to my CLI. And then if I run the same command as before, get services, pods, deployments, and stateful sets, what you should see is another entry for demo DB2. So this is the third line from the top. So again, the same endpoint has now been registered and published in the Kubernetes service catalog. So the port number I was talking about in the web UI should match the cluster IP and the database name that we created using the web UI. One final sort of step in this demo is to kind of show you how quickly these registrations appear and disappear. So if I come back to the web UI and say I'm done with this demo and this database, once I quickly delete the database using the web UI, what will happen again on the Kubernetes side of things is first the Redis cluster and the cluster manager will delete that database, and then Redis Enterprise controller that has been deployed on the cluster will notice that event and get rid of that entry from the service catalog of Kubernetes. So let me clear the screen a little bit, and if I run this command again, what you will notice is there is no longer a demo DB2 entry in the CLI output. So I think that was a very quick and fast demo of a running Kubernetes Redis Enterprise release. I have a few more slides around the Redis Enterprise release. So let me switch tracks and go back to my presentation. So I think we left off the deck on this slide where we talked about how to do the deployment. During the demo, what you saw was me doing a load test where we showcased performance of about 1.5 million ops per second with 0.6 millisecond latency. So extremely fast and very high throughput. Now, I wanted to sort of share this slide here because essentially what I wanted to get the message across here is we have some great partners, and Pivotal is one of them. So on the Pivotal is also working on a Kubernetes release called Pivotal Container Service. They're calling it PKS. So these are a couple of static screenshots where I'm showing you that I have a Redis Labs PKS cluster. And then on the screenshot below, or the bottom half of this deck, what you're seeing is essentially the same footprint that I showed you in the demo. You have a Redis pack and a headless service. You have a load balancer on line 2. You have a 3-node deployment. If you look at the node, which is on like halfway through the bottom image called node, there's a VM with GUIDs. That essentially is telling you that this is a PKS cluster, and these VMs have been spun up using an orchestration tool called BOSH. But the whole idea of this is to showcase that not only are we able to deploy our generally available Kubernetes Enterprise on a vanilla Kubernetes, but we also can deploy it on particular distributions from some of our partners, like Pivotal's PKS service and distribution. Another quick one to highlight is our capability to run on OpenShift. Again, Red Hat is a good partner of ours, and we are working closely with them to get our Redis Enterprise certified on OpenShift. We are certified on OpenShift. We are working through a few of the last remaining certification procedures to get it released. But essentially, once again, if you look at the OpenShift container platform screenshot, you will start to notice the same pattern. Since OpenShift is based on Kubernetes, you're going to see the same set of resources being deployed and used. So in this example, once again, it's a 3-node deployment example. So you have Redis cluster 0, 1, 2. We have deployed a controller on OpenShift environment. So that's being highlighted here as a pod. We do have a Redis cluster running on it. An additional example here is a service broker. So OpenShift has this concept of Open Service Broker API. So we are working with Red Hat on introducing that functionality on OpenShift as well, which is part of a Kubernetes release. So these are like a couple good examples of our partnerships that we're working on with Red Hat and Pivotal. So let me just quickly recap what you have seen so far in the demo. You saw a static image of me deploying a Helm chart for this demo. I was able to walk you guys through all the footprints of a typical Kubernetes deployment. So we walked through the get pods, get services, get deployments, and get stateful sets, CLI output. I quickly showed you how to create a database and what that looks like in Kubernetes using the kubectl CLI. I was able to showcase the controller functionality where those new database endpoints were automatically getting published in the service catalog. I started off the demo by showcasing the fact that I have deployed a mem-tier benchmarking tool as an example of a client, and then we kind of showcased the throughput and latency issues as it relates to Redis Enterprise on Kubernetes. And the final thing that I did in the demo is to showcase like what a delete looks like from a web UI perspective. I could have very well done it with a curl command and our API and APIs, RESTful APIs, but for this event, I chose to use the web UI to delete a database, and we saw that demo DB2 get deleted automatically. So one final slide here, and then I can open it up to questions. So the key takeaways from this event is we have a Redis Enterprise Kubernetes release. It is GA. It is based on Redis OSS, so it is using Redis 4.0 and above. The Docker image for our Redis Enterprise Kubernetes release is available on Docker Hub. The current version is 502-30. We are closely following Kubernetes 1.8 and 1.9 releases. I know 1.10 just came out last month, so we are working on doing the final QA of it before we announce support for 1.10. And as you saw in the demo, we have a Helm chart, and I use that Helm chart to do the Redis Enterprise deployment. Now, some of the things that we are working towards in the future are around OpenShift integration. So I gave you a very quick insight with a static image of what that looks like on an OpenShift partner side. I showed you a very quick static image, but a similar footprint of our Redis Enterprise release running on a PKS cluster published by Pivotal. And then on the Red Hat side, we are working on publishing an open service broker-based API in the OpenShift world and ecosystem. And finally, we are also working towards a Prometheus integration for our Redis Enterprise release. I just wanted to mention a few resources that you can take a look at the end of this event. And we welcome any feedbacks you may have on our Helm charts or Docker images. So you just wanted to mention that and how you guys can reach us so that we can continue these conversations. So with that, I think I am coming to the end of my webinar. So let me quickly go back to the key takeaways section and open it up for questions. So the first question that I see in the forum is, do you encourage sharing Redis clusters across multiple applications? Or should you have each application have its own cluster? I think that's a great question, and I think that's something that I forgot to highlight, is Redis Enterprise by itself has multi-tenancy built into it. So one cluster can actually support multiple databases. From a microservices perspective, you would want to have at most one or two applications bind to one single Redis database. But a Redis Enterprise cluster can have multiple databases, and they have multi-tenancy built into it, so you are able to control access to it, and you can bind different apps to different databases, all running on the same cluster. So let's talk, so hopefully I have answered your question. So let's talk about the next question that's in the forum. How many pods are inside one of the pods? I think the question is, it's a fair one. It's around, I think you probably meant how many containers are running inside a pod. So the answer is, we are trying to maintain a 1-to-1 ratio of a Redis enterprise node running inside of a pod. So for now, it is 1-to-1. So let's talk about the next question. Does this cluster have one master and two slaves? So great question. So this is going back to Redis Enterprise and how the Redis Enterprise is architected. We try to maintain the same architecture regardless of your deployment model. So what we have in Redis Enterprise itself is a master is the one that is receiving all the traffic, and it is a master-slave setup. So when a master fails, the slave is automatically promoted, and that failover is transparent to the user because we are taking advantage of the enterprise features like a super fast, low latency proxy that we have introduced in the Redis Enterprise product. But I think that was a great question, so keep them coming. Let's go to the next question. Please summarize the crux of using Redis with Kubernetes. Again, that's a very good question, so let me tackle that one. So I think I quickly introduced Kubernetes and why you would want to use Kubernetes. So if you are trying to break down your monolithic app and you have decided on a container platform, and it happens to be either Red Hat OpenShift, Pivotal Container Service, or a vanilla Kubernetes, then what your applications will need is the ability to connect to a persistent database in the back end. And having Redis Enterprise running on the same platform as your application will definitely reduce the hops and the latencies involved if everything is running on the same cluster. So hopefully that answers your question. Like if you are building microservices and you are trying to deploy those applications on Kubernetes, then it makes sense to have Redis Enterprise running inside of the same Kubernetes cluster to reduce network latency and other issues involved with traversing, different systems. Another good question here is, how can we scale this Redis stateful set based on load automatically? Well, in Kubernetes, the idea here is to, give you that scalability so that when you run into a heavy load situation, you can quickly scale up your stateful set. So I think the scaling up activity is fairly simple and straightforward from a Kubernetes perspective. So you can just do Kubernetes scale up event on the stateful set. So that will bring up a new Redis Enterprise node, and it will automatically bootstrap it to an existing cluster of Redis Enterprise. And that will give you the ability to take on more load or expand your cluster without having to sort of bring down the cluster or any downtime that a user or an application will notice. I think we have time for one more question. So let me see here. How about multiple masters and sharding in Kubernetes? So again, this is pretty much a question that is core to the product itself, not necessarily specific to the Kubernetes release, but yes, we do have the ability to have masters running on different nodes, and you do have the ability to do a shard placement strategy that may be dense or sparse. And again, all that can be controlled in Redis Enterprise product itself. And we can definitely do that in the Kubernetes-based deployment model as well, because we are using the same symmetric software. So the workflow is not going to change. The core capability is not going to change. Only the deployment form factor has changed. So I think that brings us to the last question. I think we're running out of time, so I do want to give it back to the organizer to kind of quickly, summarize. But essentially, I just wanted to quickly summarize that Redis Enterprise Kubernetes release is GA. Helm charts are GA, so please give it a try and let us know if you have any feedback for us.
Hey, Vic, great. Thanks a lot. Everyone on the call today, thank you very much for joining us. Hey, go to redislabs.com/webinars and check out some upcoming webinars and register today. An email with a link to the recording will be sent to you in the next day or so for you to review at your leisure and also to share with your workmates. Again, thanks again for joining us and make it a good day. Bye-bye.